Physical choke points dictate the flow of the global economy, and when they constrict, the entire supply chain reacts with mechanical fragility. Brent crude reached $98 a barrel this week, while Iranian oil, traditionally discounted, now sells at a premium to global benchmarks. These screens at the CME show how markets process physical threats into financial data. The CME, or Chicago Mercantile Exchange, is a global derivatives marketplace where the price of risk is calculated in real time. We have built a flawless machine designed to measure shortage and instability, providing a high-definition view of every emerging risk. Mathematical models used by analysts to predict supply chain disruption are accurate, yet they remain incomplete. This creates an asymmetry of measurement. The infrastructure required to track a crisis is massive, while the infrastructure needed to measure the human adaptation that follows is virtually non-existent. As this diagram shows, focusing exclusively on a global ledger of scarcity casts a statistical shadow over the reality of local survival. Measuring the exact severity of a macroeconomic shortage fails to account for a system's actual ability to withstand it. Looking past the high-altitude, satellite-level data reveals a completely different set of mechanics operating down at the neighborhood level. Rising fuel costs trigger immediate shifts in behavior, with commuters moving toward carpooling, walking, and biking as they rediscover their immediate surroundings. Constraints on global shipping predictably drive a resurgence in hyper-local food sourcing, turning urban vacant lots into productive community gardens. When macroeconomic sprawl slows down, local ecosystems receive a reprieve. Watersheds, the areas draining water into a common outlet, begin to recharge and clear. These community actions represent a built-in system of systemic resilience that deploys automatically during a macro crisis. If this localized resilience is a predictable reaction, we must ask why it remains absent from our economic forecasting. The data for this survival is already being recorded through municipal bike lane counts, local garden registrations, and time use surveys. Contrast the high visibility of the global oil price on the left with the fragmented, disconnected dots of local adaptation data on the right. This local data is effectively invisible because it sits in thousands of separate municipal ledgers rather than a unified feed. Our current blindness to community strength stems directly from how we aggregate or fail to aggregate this information. Upgrading our scope of vision does not require energy companies or institutions to change their core business models. A sovereign network provides the necessary architecture, acting as a digital infrastructure that links these scattered local ledgers. By co-building this network, energy companies and utilities can see the data that single, isolated platforms cannot process. Interconnected data reveals the specific local patterns, like garden density or transit shifts, that indicate which communities are best positioned to withstand the next supply chain shock. Mapping these ledgers allows institutions to measure the invisible mechanisms that sustain their customers when macro systems fail. We focus on physical geography, but the rigid data grids we use to classify our world act as a more restrictive barrier. The bottleneck hiding the other half of the story limits our understanding of global stability far more than any physical strait. When we see only the shortage, we overlook the adaptation. Moving past the fragments of a broken dashboard allows us to build the sovereign network and finally see the whole board.